Hello everyone, thank you to let me the opportunity today to exchange with you about circular construction. Our world is facing a really huge challenge, and when we look at our global CO2 footprint, we realize that the building where we live, the building where we work, the building where we do sports are representing 44% of the global CO2 emission. Today, general opinion is focusing a lot of attention on CO2 emitted by industry, on CO2 emitted by transportation, the trucks, the car you are driving. But we need also, if we want to sustain a way of life, to change drastically the way we build and we follow up our building infrastructure. We need to define new approach to sustain our way of life by doing buildings which are decreasing the amount of resources we are using to build them. Buildings which are decreasing the impact on the climate and are reducing the effect of the climate change. One way, if we think about steel buildings, is to really optimize the design, to really change the approach we have towards the material we use. And today it's entirely feasible to use high-strength steel to design and erect building. This will have a direct reduction on the amount of material which is used. As you can see on the slide, we can significantly reduce the amount of material which is used when we use higher strength steel. Another way is to put the right material at the right place. So to choose the proper material to do the construction, and also to choose the right steel to put at the right place. You see on the graph a comparison for an industrial building. So it's a type of building where the structure and the envelope, I would say, play a major role in the environmental cost. So when we use higher strength steel, we can directly see a big reduction in the carbon footprint, but also by choosing the right steel that you will put in the building, it can have a massive effect. Some weeks ago, ArcelorMittal has launched a new decarbonized steel on the market, which is sold under the umbrella brand X-Carb. So it's steels that are on the market that will allow you to drastically reduce the environmental footprint of the building. But that's not enough. We need, of course, to reduce the cost of our building today. But if we want to sustain for the next generation and not put the burden of our action on the new generation, we need to change our business model. We need to move from a linear economy where we produce the material, we erect the building, we use the building, and then we landfill the building. We need to change this paradigm and really entering into the circular economy. There are many ways to enter into circular economy. The first one is to think about the recycling of the material. Steel is one of the most recycled material on the planet. Why is it one of the most recycled material? First of all, because steel can be separated really easily from the other materials. Thanks to its magnetic properties, it's really easy to sort out steel. But that's not enough. To sort the waste does not mean recycling the waste. So, since the 80s, the steel industry has created a value on the market for the scrap. So any piece of steel that you will bring back to the recycling park, your car, the waste of the construction, they have a market value and they become the raw material for the steel industry to produce new steel. So the market is totally organized technically, but also in terms of value chain. Is it enough? No, it's not enough. We need again to go one step further and start to think about our construction material as a material bank. Why do we need to recycle something if we can reuse it? And when we think about steel, it can be done easily. So first step, when you think about your building, you need to think about them in a way that you can easily refurbish building. Today, most of the building that we destroy, we don't destroy them because they have structural issue. We destroy them because it's not economically viable to refurbish them. So when you design your building, you need to design them by decomposing the function. You need to have the structure which is decomposed from the envelope, which is decomposed from the internal partition. Like that, you can easily renovate, you can easily rearrange the internal shape of your building. So here it's an example of a quite massive building which has been rebuilt using the element of the previous one. So it's the Court of Justice of European Commission in Luxembourg, where Dominique Perrault has reused the structural member to build the new building. So as you see on the picture, the steel part of the building has been dismantled. The concrete part has unfortunately been crushed. The rebars have been recycled into steel, and the aggregates have been landfilled for this project, but it is today possible sometime in some region to reuse the aggregates. And then the steel element have been refurbished, and as you can see, the elements have not been reused exactly in the same architecture. They have been adapted and put in shape to fit the new architecture. On the drawings, we see in the middle a connection, which was a connection of the previous building, which is not a connection in the new building. So reuse, it does not mean one-to-one architecture. You can also adapt the architecture of the new building with the reused elements. So you see now the lobby of the building after reconstruction. It has nothing to deal, and it's totally different from the previous building. So to foster this and to, I would say, really use the potential of reuse, we need to think about the prefabrication. So prefabrication allows us to have also less people on the job site. We saw last year, and unfortunately it continues this year, that COVID crisis highlighted a lot of issues for the construction sector. And today it's far less easy to have hundreds of people on a job site. So if we rely on prefabrication of the element, we will have far less people that are on the job site and far less people needed to assemble the element. But also, what is an advantage of this prefabrication is the faster installation. Of course, buildings are growing faster, but also buildings are demountable. So here is a picture of a usual connection made with steel element. It is bolted. It means what has been bolted and assembled can be debolted and disassembled. It means that it really is the potential to reuse the different elements into a new building. So if you need to remember something from this discussion, is first of all, optimize your building. So use advanced material that will allow to decrease the amount of resources we will use. Do and design your building in the most flexible way as possible to make them adaptable, transformable. And finally, try to make design that will allow deconstruction and not demolition of the building. This will help the future generation to reuse the element that you will put today in the building. Thank you for your attention.